Good morning. Thank you for joining. Welcome to this next one in a series of webinars on computing on encrypted data. I think that we within LSEC have started just over a year ago, together with our partner from KU Leuven. The focus for us is to showcase and to bring insights in how private data, confidential data, sensitive data can actually be both encrypted and still be worked upon. We have many different technologies that can support this. At this point in time, we ourselves are more focused on a secure multi-party computation and fully homomorphic encryption, something that we won't be bothering you too much with today. But the other thing is also really that we are looking towards the different use cases that can help inspire both ourselves and yourselves in order to take, let's say, the next steps into this. So my name is Ulrich Saldesachts. I'm the managing director of the association LSEC. LSEC is a non-profit organization that has been around for about 2 decades, as you can see here. So we're celebrating this year our 20th anniversary, and you're of course also welcome to join us in the festivities which we'll be organizing a bit later on in the year. Hopefully when there's still some more COVID and Corona settling down. Because we do know that over the last 2 years and still today, the virus is pretty active, and we won't bother you too much with that. But it seems that many of our colleagues, in any case, and relatives are still being held hostage by this strange thing. So a couple of words maybe to start with on computing on encrypted data and basically what it is and why we do this. So we have basically a number of activities that we do within LSEC, and specifically for this, we organize different types of inspirational sessions, which are part of our COED project, which is called Computing on Encrypted Data. And it's part of a larger format of activities supported by the Flemish government called COEX, where the aim is really to support research and development insights into a collective knowledge distribution. So we are here really to create awareness about this existing technologies, about the fact that these potential components can be helpful in your environments as well. And specifically when it comes to privacy-related data, personal data, as we will also be seeing a little bit later on this morning with our partners here from Microsoft. And the aim is also for us to help getting some components and technologies out of this to facilitate to companies to absorb and to start utilizing the technology internally. So in Flemish, it's called vertaalonderzoek, so translating the research into components and into bits and pieces of technologies that can be put into action, specifically for prototyping and knowledge distribution. We started with this project just over a year ago in December, and just yesterday we have understood that we will be able to continue for the next 2 years, creating a sandbox environment that we have already established, where you actually can bring some of your concepts of confidential data inside, and where we'll be able to demonstrate on how that can actually compute into an confidential computing environment or an encryption environment, and then start to work with that data in order to prove how this type of concept really works. Specifically because, of course, we are backed by cybersecurity companies. One of the first targets there is sharing of cybersecurity sensitive information between companies. And we will be doing that together also with some European certs. So cybersecurity emergency response teams throughout Europe, where we'll be actually sharing some of the company data that they are looking over with in order to help them in a faster response and into helping them also creating a better insight in their cybersecurity background infrastructure. So beyond this, we'll be likely also organizing and reorganizing, apart from the webinars, also some activities directly in person. The last one that we did was in October of last year. And so the next ones will be likely in a couple of months' time again. we'll be hopefully basically ready to see you and to meet you directly in person. We have also developed a couple of websites. One of them is hosted by us. It's basically called computingonencrypteddata.com, so that makes it easier. But also our partners from KU Leuven have developed a number of information sources that might be helpful. And we have quite a number of video materials, as the one of today will also be focused on. Our aim in the end is really to help companies in Flanders, in Belgium, to start utilizing the technologies, and that we can actually improve the security of your companies, but also to help improving products and services that are built upon this type of technology. So we have our specific aims for this. We've already realized more than 15 of those innovation trajectories, but we aim, of course, to reach out to many more of you and to help the company specifically in doing new types of developments and new types of innovations with this technology. So having said this, that also means that we are very much in line with some of our partners, like in this case, our friends from Microsoft, who are really working together in a proactive way in the market today in Europe, in Flanders as well, and working on this concept called confidential computing in Azure Confidential Computing, which is basically there to investigate which potential use cases there might be. And I see that Tim is already sharing his slides in order really to see where this type of technologies can support companies and users in their challenges of facilitating their personal data, their private data, but also other types of sensitive data, and how we can help them in facilitating the improved security on this. So Tim, good morning. Welcome to you.
Good morning, Ulrich. Quickly, operational point of view, which screen are you seeing? Are you seeing the full screen or are you seeing my presenter notes? Because
I'm now seeing your full screen, and I'm also seeing you on the side of my screen. So that's perfect.
All right. Best of both worlds. Okay. First of all, thank you for having me. I'm always happy to share what we're doing from Microsoft side. As you mentioned, well, it's kind of interesting. Most people do not associate Microsoft with privacy or with confidential data. That's one of the main talking points that I have from my role as an architect, that we are mostly seen as not to be trusted. Hence why we are constantly coming out with innovation to regain that trust, I would say, and confidential compute in Azure mainly is one of those hot topics of the day. But before going on that one, maybe I'll share something about myself. For those who don't know me, first of all, feel free to reach out on LinkedIn, on social media, wherever you type my name, I will be active. I'm 5 years in Microsoft, and before that I was basically swimming around in the VMware pool, at VMware, at EMC, at distributors, at customers. So VMware is still running a little bit through my blood, so it will always be a lost love, I would say. But anyway, 5 years in Microsoft, 5 years working as a cloud solution architect, infrastructure. Internally, we sometimes make fun of ourselves as being the dinosaurs of IT. Why? Because I have colleagues who actually do the cool stuff, or at least that's what they think, doing the data, doing the artificial intelligence, doing all the very, I would say, hands-on technology that you see in your daily life. Whereas the infra team, which I'm part of, is more doing the behind-the-scenes stuff, because I always say even the AI stuff and all the chatbots and all the cool stuff is somewhere still running on a CPU, a memory, and a disk, which is still the old school infra, which is actually where my passion is laying. Besides being a CSA, so a cloud solution architect, for the past year, I've been also assigned as a tech lead for Azure Belgium Central, which is an upcoming Azure region within our country. So it was announced late last year, and it's foreseen to open somewhere over the coming 2 years, I would say, which I think really fits into what you said before, Ulrich, I made a note, that's why I'm looking at my notepad, on the private data and the PII data, which is typically a discussion that I have with customers who who really like cloud, but then comes into play regulation, governance, whatever that prohibits them from putting the data in a cloud that is not in country, for example. So the Azure Belgium Central region will hopefully help us, but mainly our customers to take away that blocker of not being able to use cloud. And then on top of that, the confidential compute part, which I will talk about today, will make that even more easy to swallow, I would say, for legislation, for government, for whomever puts on the limitations of where you can put data. Within Microsoft, my passion is, well, of course, confidential compute, but also the Azure VMware solutions. Because why? Well, I explained I have been working within VMware ecosystem for the past, I would say, 15 years. And since a year or two, we also have VMware on Azure. So for me, it was pretty much homecoming when they announced that. Also meaning I'm probably like the go-to person, because most of my colleagues have been Microsofties for their life. So for them, VMware is very unknown. For me, it's like yeah, comfort zone. So hence why I also have that as a passion and also as a specialty within the team. The agenda for today that I want to talk about is, first of all, I want to set the scene to make sure that we are all on the same page, that we all know what confidential computing actually means. I will talk about what we're doing from Microsoft's point of view, so how we see it, what we are developing, what is available today, what's on the roadmap tomorrow, what we are announcing very soon, or like day before yesterday. I'll share some use cases, some customer stories. So either customers already have it and use it today, and probably on apps that you are actually using, but also on more of, I would say, a proof of concepts, where they are thinking of how can we fix this issue, and is confidential compute a way to do it? So I'll touch on both, and then I'll briefly touch on the actual products we have. I'll try not to focus on that because that's not the goal of my session today. I mainly want to make you aware of what is existing confidential compute, which is not really a Microsoft, I would say, exclusive technology. We are ahead of the pack, but it's not based on Microsoft technology. It's actually based on AMD, on Intel, on NVIDIA, on ARM, on those kind of things. So it's really, it's not a lock-in. That's what I want to say. And I'll touch on how we took those, I would say, Lego blocks and made our models from it. But in essence, the idea behind it is the same for everyone. So looking at what confidential computing is, I would say I have no idea on the average age of the audience. So for some, I will be sounding like a dinosaur, and for other, maybe they will feel like we're talking the same language. But basically, it's all about encryption, right? And the first one that has been around, I would say, probably from even before I joined the IT crowd, has been data at rest, meaning the encryption of the data on the disk, right? So, for example, use case, someone walks in the data center, pulls a disk out of the rack, runs home with it, and wants to read your data. Well, that will not work because the data is encrypted. So that's data at rest, and that's fine. That's been around for years. It's a proven technology. It works fine, but it's not end-to-end safe. So next up, the next one that came is data in transit. So think of VPNs, TLS connections, moving your data from A to B in a secure way, preventing man-in-the-middle attacks, and so on. That's also, I would say, been around for probably the past 20 years or so, working perfectly. And those two, for me, are like, I would say, the two legs of a three-legged stool, and there is still one missing, which is of like obviously the data in use part. So when we save the data, it's encrypted. When we transport the data, it's also encrypted. But at the moment that we start using the data, so we open a file, or we process a database, or we run a query or whatever, basically what happens is that the data will be back unencrypted in the CPU, in the memory, hence causing a potential risk of breach. And that can be from in our case, Microsoft can be looking at my data because they are the cloud provider. It could also be malware that has been installed on the machine, or it could be your own colleague who is a rogue VM admin or whatever. Any potential scenario that you can think of, which is, let's be honest, not always very likely, will be protected by the data in use ID. And I'm saying it's not very likely because, for example, if you want to read the data from within the CPU, it probably means that someone is actually in your data center connecting cables to your server. So chances are slim that that would happen. But for some customers thinking of FSI, thinking of military, thinking of PII data, for example, just having the chance that it could happen is a valid reason to not do it. Thinking of GDPR, for example, having a breach on personal data from your customers or from civilians or something will probably end in your company going bankrupt, or at least having a severe fine that will hurt for many years to come, and you lose the trust of everyone. So it's really it's a hot topic. It has been a hot topic, and I'm sure it will become worse because I think it's a good thing that legislation is pushing hard on this. And I think personally, as well as of course from Microsoft's point of view, that the confidential computing part will help us again take one step or many steps forward to reaching the holy grail of having the data secure in any form, at any place, in any use case. And that's where the data in use, so confidential computing, basically comes into play. On top of that, so basically this is what I said. So you have the storage, you have the transfer, but thanks to the data in use, you will also lock down the cloud, but also lock it down during processing, or for example, while doing reporting, analytics on data, machine learning, those kind of stuff that and will also be locked down by data in use. I know this sounds very abstract at the moment, so hence why I will come back to very hands-on examples that you either already know, or you will be like, oh, okay, I didn't think of it like that. And then it will all hopefully make clear, and all the pieces of the puzzle will make one very shiny image for you all. The main idea is to protect you from malicious admins, insiders, but also hackers. I mean, I think all of us are very much aware of what has been going on in the world with, for example, MediaMarkt was hacked, but you hear about universities getting malware. You hear about several companies every week getting hacked and then having to pay Bitcoins or whatever to get their data back. But also I would say third parties. It could also be less, I would say, action movie like, but it could also just be you're collaborating with a partner, and that partner decides to take your data and sell it to the highest bidder, or to maybe even not on purpose copy data somewhere that is not aware of the PII data in your data set, and by silly coincidence creating a huge breach that will cost a lot of money to a lot of people. So it's not always the comic books or the action movie kind of breach that you should think about. It's sometimes just happening in front of our own two eyes, not having any awareness of it. And that's the vision of Microsoft. So that's why we're saying what we want to achieve by using conventional computing is to move our cloud from a normal cloud, I would say, to a confidential cloud. So after today, you'll see we have several products available in confidential computing, but by far every Azure component is supporting confidential computing today. It's my belief that will change. So I think if we would have the same session 2-3 years from today, we'll probably be talking about a confidential cloud instead of a cloud, meaning that confidential computing, in my opinion, will become the de facto standard of doing cloud. And I honestly also see that happening on-prem. So it's not only a cloud story. I could for sure see that in local data centers happening as well, because the technology is exactly the same. It can be used on-prem as well. And honestly, I think that's where we're going. That's what I'm seeing from demands from customers, but that's also what I'm seeing on our side from roadmaps, from where are we putting focus. And it's always coming back to, we need to create trust with the customer, helping them to treat data safe. And I think that's where confidential compute will come into play more and more down the road. Now, why Microsoft? Why Azure? I already mentioned it in my introduction slide. The components itself are not exclusive to Microsoft, which is, in my opinion, a good thing, because if you keep something only for yourself, it will never become a standard, right? Well, Microsoft feels the same, and that's why we are also founders or co-founders, I should say, of the Confidential Computer Consortium. If you don't know that, I really welcome you to have a look at the website. No need to Google it. I put a slide with all the links that I talk about at the end of my slide deck. So I'll be happy to share it, and then you can read all the links, watch all the videos, and what else that I talk about during the session to read up. What else is interesting to know? We are announcing stuff a lot lately, but as you can see from the screen share or the screenshot I pasted in my deck, we have already been making announcements from Confidential Computing back in 2017. So for those who don't know him, Mark Rosinovic is our CTO for Azure. He's quite well known, I would say, in the tech community. If you don't know him from Microsoft, maybe you know him from sysinternals, which has been, I think, a tool set that every IT admin knows from back in the days. It still exists today, and it was actually Mark Rosinovic who published that, who invented the tools. And he's our CTO today, and he's always on the forefront of new technology, and confidential compute is something that he talks about a lot at our conferences, but also internally. He's the one putting a lot of focus on that. So it's really a thing from Microsoft Research, which is pretty much, I would say, a consortium where we collaborate with universities and so on to develop new technology, to, for example, the quantum computing and stuff like that. That's also going back to confidential computing. So all the findings there are also going back into the same consortium as a knowledge share. And to give you an idea of other parties who are part of the consortium, so it's Microsoft as a premier member, but there is, for example, Google, there is Red Hat, there is Intel, Huawei, ARM is there, even Facebook is there, which is kind of interesting given the fact that they have been in the news a lot with acting less confidential, I would say. And then from I would say hardware point of view, the main one that you will know is AMD. NVIDIA is there. You see VMware as well, for example, Cisco. So it's a big team, I would say. It will only expand, and the idea that everyone shares their findings and standardize on the same mindset. So why is it important? Like I said, if we come up with an idea, but only we are doing it, and it becomes a lock-in, and then it will be difficult to make everyone being confidential. And I think confidentiality and the ways to make that happen should be a standard that everyone can adhere to. So if it's only for Microsoft or only for Google or whoever, I don't think it will ever get enough traction to become a standard. So hence why I think this is great. And if you go to that website, you will also find white papers on how it is done, on performance testing, on how are we validating if something is actually confidential, how should you treat PII data. So there are a lot of white papers and articles and benchmarks from all the different companies who are basically sharing back. So really, if you're interested, have a look, have a read. It's always nice to read up on those things. And then it's not coming from one vendor, it's coming from all the parties. So you have some comparison between all of them, I would say. What else? So use cases, right? So I already mentioned it a little bit. This is from our point of view, I would say. So where are we seeing the most demand for this kind of technology? There are three pillars today, which is government for obvious reasons. Thinking of Belgium, Rijksregisternummer, so social ID number. That's something that you don't want to have leaked on one storage bucket left or right because someone forgot to encrypt data or something. But also for example, national banking systems, for anti-corruption, for tax fraud that you want to detect, maybe for justice, where you might want to save the evidence data in the cloud, but today you cannot because, well, if that kind of data gets leaked, maybe a court session will be invalidated because of that. So they are very scared to do that. And maybe with confidential computers, kind of things can actually be made possible. So the list is endless from government point of view, but it's also coming from FSI point of view. And the obvious ones, any money laundering, Bitcoin, for example, I think those are very common sense, I would say, but there is also from not the fear factor, I would say, but from a more business creation factor, which I will explain also a little bit later as an example, where financial services also benefit from confidential compute, and not just to prevent money laundering schemes or I don't know, cyber criminality. So those I think are the obvious ones, but the one that I will try to highlight are actually showing you how this can bring in more business and not just prevent you from being attacked, which is the typical pitch I think you would hear from confidential compute. And then healthcare, and I think that's also very important. This is where we also hopefully can make actually a difference in the lives of people. Meaning, for example, take one pharma industry that is developing a medicine to prevent some sort of or to heal a cancer, right? And you always have multiple parties who are working on the same goal. For example, I want to cure cancer X, right? And typically the first one who comes out with a medicine or a cure is the one who will make the money. The issue is that they all have data, they all have test patients, they all have drug trials and so on. And actually they would benefit from being able to share that data with other pharma parties. But then the issue is, hey, I don't want to share my IP, so I don't want to share my intellectual property, but I also cannot share the PII data of my test patients, for example. That's really, really not gonna be perceived well by the world if that would happen. So in the end, everyone is working on their little island and spending a lot of money, and it's going slow. If they would be able to collaborate, share data without actually sharing data that they do not want to share, and having proof and a certainty that it's not happening, so that they are not sharing the data that they do not want to share, that would actually allow them to collaborate, benefit mutually from the findings, but still be able to keep to themselves what is exclusive to them, or what they need to protect, for example, from customer data. Contact tracing, which is a very hot topic the past 2 years, I would say, is also something where this can help. I mentioned drug development, but it can also be, for example, maybe more hands-on, if you would be able to share the X-rays from people from their lungs, for example. You could share the findings from one hospital with the findings of another hospital, put the data sets together, and then maybe be able to detect lung cancer 2 months earlier, because your data set just doubled and you have more material to train your AI models, for example. And today, a hospital is typically limited to their own data set, and they do not want to share it because of, again, PII data, medical data. Thanks to confidential compute, you could make those things happen as well. And then we are not preventing us from being attacked by malicious parties, but we're actually giving back to society, giving people maybe a better chance of survival when getting sick. So it's not always we need to protect ourselves from the bad world out there. It sometimes also means we can do better for other people, or we can make more money, or we can develop new businesses between different parties and so on. So I really want to stress, it's not just a technology just for the sake of security. It's also just for doing more with less, I would say. And then some customers, and I want to talk about 2 of those. These are public reference cases globally. We are already working with some customers in Belgium. Those are not, I would say, public reference cases, or not yet at least, so I cannot talk about them at the moment. But the one that I really enjoyed reading is, for example, the RBC one. RBC is Royal Bank of Canada. It's, I think it's the largest bank in Canada even. And what they wanted to achieve is the use cases, for example, they hand out a Visa or MasterCard to their customers. And they have the data of, okay, I don't know, Pete is buying €1,000 or US dollar or whatever every month at store X. But they do not know what you buy at store X, right? So they only know how much you spend at a certain store. And on the other side, if you take that store, for example, let's take, in our example, take the Laser. The Laser would know what you as a customer buy. So they know that you like pizza and you like to drink Coke and you like to eat salad, but you do not like potatoes, I don't know, whatever. They have that data, but they don't know where else you shop. So they don't know, for example, Pete is joining the Laser to buy his pizzas, but he's buying his candy at Colruyt because we don't have the right candy in our stores. Whereas at the other side, the RBC bank, they know exactly where you spend your money at what store, but they don't know what you're buying. And what they wanted to do is they wanted to create an offer to their customers from RBC point of view, where they say, hey, I know that you use your Visa card at Deleuze and you are really interested in pizza and in whatever you buy there. You know what? If you use your Visa card again at Deleuze and you buy this kind of pizza, then I will give you a €5 discount or whatever. So they can, basically what they are doing is they are taking the data from the stores, so Deleuze and so on, and combining that with their data from what you are doing as a customer with your payment card. Neither of those data can be shared because it's PII data, but what they do, they put the data in a combined data set that is protected by confidential compute, and only the model that is actually training the profiles has access to both data sets. That is attested thanks to technology that I will explain a little bit later. So both parties know and can prove that the data is not being accessed by anyone else, and still they both get back a model that they can use to drive more business. So RBC knows who they should target with deals, and on the other hand, the store forefronts, they know, okay, people who buy this and this typically also want to buy this, but they go somewhere else because we don't have it. And if they have that data, they can change their assortment of products and get more money out of it, because then you don't go to another store. So that's the use case they're doing. It's a use case that is actually, it's in production, so it's running. And well, this is just a real short recap on our website, which I also added in the links. You can read the full story from the point of view from RBC as well, and then they go more into depth. So that's a great story. And then the other one that is probably closer to home is the Signal story. So I think the audience here all is probably using Signal. For those who don't or don't know it, which I would be amazed by, it's a WhatsApp alternative if you want, but more safe, because as you know, WhatsApp is part of the Meta group, so Facebook, and there is a lot of controversy on what are they doing with my data. Are they reusing it? Are they selling it? Can they deduct knowledge from who I talk to, and so on and so on. There has been awareness on that, and people are moving away from it, and hence they are moving to Signal. And what is Signal doing? Well, Signal is actually running on Azure Confidential Compute. So in the backend, they run their workload on Intel SGX Enclave. So basically on a trusted compute environment in which that the messages are processed. And thanks to using that, basically what they are saying and what is actually happening, they cannot see what is happening within that secure enclave. So Signal cannot see your messages, they cannot see your contact list, so they can also not use that to deduct data from it or correlate stuff or sell your data to someone else. And they have been using the Azure Confidential Compute stack for, well, from my knowledge, since the beginning of Signal. They have been an early adopter of our technology, and they're still growing at a fast rate nowadays. And for those who don't know what a secure enclave is, for example, if you have an iPhone, your Face ID, if you use Face ID, so the authentication scanning your face, that scan of your face is not being sent to Apple's cloud. It's saved on a chip, on a hardware chip in the phone. Hence why if you move to a new iPhone, and you restore your backup, you still have to rescan your face. You have to retrain the model to recognize your face, and that is because that data of what do you look like from a Face ID point of view is not saved anywhere. It's only in the chip, in the secure enclave on the phone, and that secure enclave is the same principle of what we use in confidential compute. So just to bring the example a little bit closer to home. That's what they do. This is just an example of the payment fraud detection. So it's, in essence, it's always the same story. So I gave the explanation of pharma or of hospitals sharing data. This is the same example of banks sharing transaction data to be able to detect payment fraud. So instead of only having their own data set to try to detect if one of their customers is doing really weird stuff, they can share the data between other banks. without actually sharing the PII data or the financial data of their customers. And then they can train the model better and detect the anomalies, I would say, in transactions to be able to faster detect someone is stealing money or avoiding taxes or laundering money or whatever, and then of course benefiting them as well. So in essence, once you understand the concept, it's always the same thing that happens. They're just being transposed to another industry. So healthcare, pharma, finance, autonomous driving, whatever you can think of. It's always the same idea behind the scenes. A good example, I think, also again, something that's probably not really associated by a use case for confidential compute is our HR scenario. You can actually, if you're interested, you can deploy this and try it out because it's on GitHub. So we have shared a complete repository that you can just run ARM templates or deploy it as a service and then have a go with it. I'll explain the left side first, then I'll explain what we have from technology, and then I'll come back on how we can make it confidential aware. So the storyline goes as follows. Basically, what you have is you have, let me see if I can turn on my laser pointer. What you have is you have a SQL database that is storing salaries from coworkers, right? You have traditional logging, so who has entered something, who deleted something, and so on and so on. On the front end, you have a VM running an HR web app. So I don't know, a portal where the HR admin is entering your pay, or maybe you got a raise and they are changing the numbers so you get more on your bank account next month, and so on and so on. I don't know, stuff like that, stuff that an HR admin would do, right? And then someone else who is in this story is basically the SQL DBA, so the administrator who is using SQL Server Managed Studio to do his job, to manage the SQL database, to make sure that everything is fine, it's running smooth, there are backups being taken, and so on and so on. So that's the storyline. Now, the danger in this story is it could come from different ways. So you could have, first of all, you get to have a curious VM admin, right? So the person who is in the IT team, of course, managing the machine hosting the SQL database, he could have an interest to find out what everyone is earning because he has his review coming up next month, and he wants to go in with a lot of knowledge and state that he needs a raise because he feels he's underpaid, and basically he can prove it if that's the case. Or just out of interest, I don't know, whatever his motivation could be. So that's the first, I would say, threat that you could have. The second one that you could see is, well, if it's running on cloud, it could be your cloud provider, it could be Microsoft in this case, right? Or maybe you're using a managed service from a partner, and maybe the admin who from your partner who is doing your IT work could also be someone who is interested in knowing what you are getting paid or what the company is paying their people or whatever. What is not on the screen, it could actually be the HR admin as well, right? Since he has access to the tool, what is stopping him from like changing his own salary, right? He could maybe add a few euros every month, it would not get noticed, and after a few years he would be doubling his salary without an issue. And then last but not least, there is the SQL DB, the guy who is actually managing the SQL DB, who is being able to run queries on the DB and change them. He could actually also just change his own salary within the SQL DB directly without passing through the web app. And of course, and it's showing everything is logged, right? Everything that you do is getting logged, but nothing is preventing you from changing those logs or deleting those logs. And then sure, you might see someone has deleted the logs, but you cannot see what was deleted. So good luck finding out what has been changed versus what was there the day before, right? That's a little bit the use case of what we have today at a lot of companies. And I'm not saying that this is happening in every company, that people are doing that, but it could happen, right? So that's the storyline. It could happen. This is an HR app, but this could also be something more critical that could threat lives or safety, country safety or whatever. Before I explain how we fix that, I will explain all the different building blocks that we have to fix those things, and then I'll pitch back to the same story and explain how we are preventing all these things from taking place thanks to confidential compute. And this is not a, I would say, a future product or a a concept that we are thinking about is, I think every company of more than 2 people probably has some sort of HR team or an HR application at least to take care of this, or is using a partner who is doing it for them, but they also have an HR app, right? So there is a lot of stuff to think about on that point of view. Now the offerings that we have, so basically this is how we translate the technology to Microsoft technology. And what I want to do is I want to move from bottom to top, right? So I mentioned already that we are part of the consortium. We have Microsoft Research constantly feeding the consortium with what we find. The layer on top of that is really the hands-on hardware layer. So the Intel CPU, so the Xeons that have the SGX chip, so the secure chips that I've been, the secure Enclave. But there is also AMD who is doing the same thing, and then there is ARM who is also doing the same thing. From a hardware point of view, the one that is still missing here and that was announced I think last week was NVIDIA. So we're adding NVIDIA GPUs. So basically NVIDIA graphic cards that also have a secure enclave on the graphics card itself for certain use cases, which I'll explain also a little bit later what they can bring to the table. And then on top of those, I would say hardware technologies from the main market leaders, we have built our own solutions. So from Microsoft Azure point of view, we have virtual machines that run on top of the Intel SGX ones. So those are the DCS-V2. It's not really important to name at the moment, but we have the same thing for the AMD machines, and we have trusted launch machines, which is, I would say, a first step towards confidentiality from a VM point of view. And again, I'll explain what it is. This is just to set the scene on what we have available today. We have confidential compute in IoT edge devices. For example, think of remote cameras, maybe not for safety, but think of a product line where people need to wear a helmet and wear safety goggles and cannot play on their phone while keeping an eye out for the robots or whatever they are doing. What we already have implemented at many customers is that you use video cameras with AI running on top of that. And they basically are able to see person X is not wearing a helmet and he should be wearing a helmet where he's at the moment. And what we can do is then basically identify that person, send a message via Teams through a chatbot to his direct manager to say, hey, Pete is not wearing a helmet. Please ping Pete and tell him to put on his helmet. And then you could deduct from, for example, if Pete has done that 3 times in a week, Pete will get a warning, or Pete will be forced to take a training on safety on the work floor, or whatever you can think of. But again, that data is probably PII data because you're taking video streams of people. So you want to have it confidentially treated. And again, this is where the confidential compute comes into play. Those are still, I would say, to talk about myself, the more the dinosaur IT stuff. So this is virtual machines. This is still a server instead of one that you can actually touch. It's a virtual one, but it's still a server on which you have to install an OS and then deploy the application, and that's awesome. And I personally like it, but it's probably not anymore what people want, what customers want. They want to take it a step further, move to PaaS service or even SaaS. And then that's what we did. So the confidential services, as we call those, basically this is platform as a service. So we have SQL Azure, so the platform as a service SQL version of Microsoft, which is supporting confidential compute. So we're actually being able to run the queries encrypted while in use. So not only in transit or at rest, but actually while SQL is running the queries. We have Azure Key Vault, which is key management system. So where you would store your secrets. Instead of hard coding a password, for example, in an application, you would store it in a key vault. And then you would authenticate to the key vault through, for example, Azure Active Directory or a certificate or a token or a one-time only password or whatever you like. That's the basic key vault, I would say, that we have. What we also have is a managed HSM Azure Key Vault, which is the same story, but instead of being a shared service, which is still secure, by the way, but it's not secure enough for some parties. This one is actually running on top of the Intel SGX enclaves again, and it's dedicated hardware for one customer. So it is deployed in the tenant of the customer, and it's only used by that customer, and the hardware is really dedicated to them. So that's I would say, the deluxe secure version of the traditional Key Vault one. Another one that's actually free to use is Azure Attestation. And this is basically just a service that will allow you to validate that the VM, for example, that you reach out to has not been tampered with. So what this will do, for example, if you are trying to launch an application or send a dataset to a VM to do some modeling or whatever, what you can do with attestation is first validate via, for example, the TPM chip of a VM, that the OS, the drivers of the machine and so on, have not been altered and are actually the versions that we attested that are secure. So why is it important? Let's say that you would have a malware attack or a hack, and you don't know about it, and they changed a driver on a VM to be able to inject, I don't know, malicious code or read what you're doing or whatever you can imagine. Attestation will catch this and then basically stop you from using the VM and give you a warning. So attestation is preventing that from happening. It's just giving you validation that the resource that you're trying to use is okay and is using the right driver, the right OS, the whatever you can see in that entire list is secure and safe to use from a confidential point of view. Azure Kubernetes Services. This is our container platform, so managed container platform. It's the exact same thing as the non-confidential one, except the hardware that it's running on top is now using the Intel SGX and soon the AMD SKUs instead of the non-SGX and non-SEP from AMD SKU. So it's just a more secure version of Kubernetes service in Azure. Yeah.
Can you just repeat the GA stands for?
Oh, sorry, yeah, GA stands for General Available. So
okay,
GA,
okay. I was guessing something of a kind.
Yeah. No, it's a great question. I'm so used to it that I forgot that it's probably not clear for everyone who is not working at Microsoft. So if there are questions, feel free to interrupt. So if I say something and it's not clear or I'm lost in Microsoft lingo, then feel free to ask clarification.
I'm monitoring that.
GA is available. It means you can run it in production and you get support if something goes wrong.
Okay.
That's in short what GA means.
Okay, got it.
And when you, yeah, go ahead, Ulrich.
Yeah, sorry, just another question in that respect. The so basically the asking for Azure Confidential Services is still optional. So it's not that it's basically standardly available. You have to turn it on.
Yes, correct. So it's basically, for example, if you would deploy Azure SQL or an Azure Key Vault, you can choose between the normal one and the confidential compute one. Same for AKM, same for a VM, you have choice. So I think choice is always good because for some workloads, you don't want to pay extra. For others, you might want because otherwise there is no way, but it's not by default standard. It's my opinion that soon will be the case. Well, soon, I mean, in a few years' time, like I said in the beginning of the deck, I think it will be the standard down the road, but today it's you can still choose.
Once you've basically migrated every hardware into TAEs, I guess. And so what about the general availability? Is that also global? I mean, is it also, can people choose on specific regions or is that limited?
Also a very good question. It's not global yet. So what we typically do, you know, or you do not know in Azure, well, we have, I think by now 65 or something Azure regions. For example, like we will have in Belgium, that's what I call a region. We have those across the world at 60 plus locations. And when we deploy new technology like confidential compute, it's first deployed in the hero region. So hero region is the one that always gets the new stuff first, and it's in every continent, so it's always close to someone. There's always a region close to you that is a hero region, I would put it like that. In this case, confidential compute is available in the Netherlands, so in Amsterdam, which is Azure West Europe, and in Azure North Europe, which is Ireland. And then you will see down the road, we will add more regions, but today, the main limitation to having it everywhere is actually chip shortage. Chip shortage, that's a difficult word. For sure, I don't know if any one of you is trying to buy hardware or maybe is into gaming. I am into gaming, and if you want to buy a GPU, well, it's getting a little bit better, but you are paying like twice the price of a GPU. And it's the same thing for CPUs and for a lot of stuff. Even for when you order a car, you have to wait sometimes over a year because they have shortage on the chips that go in the car. And this is the same issue that we face at the moment. We cannot get enough hardware from the vendors to be able to deploy it everywhere today. So it's a global issue. It's not a Microsoft issue, but that's what it is today. So we have to pick the regions wisely, and we're doing it for us. I think for everyone in the call, it's probably Amsterdam is the most interesting one. And we also aim to get this in Belgium when we open. And like I said, it's approximately 2 years down the road before we will be GA with the Azure Belgium region. And for sure, you know, in IT world, 2 years is eternity. So by then, maybe we will say everything is confidential or it's available everywhere as an option. I don't know, but that's where we are. It's a good question. And maybe while I'm there, if you see preview, there are 2 previews that we have at Microsoft. You have either a public preview and you have a private preview. If it's a private preview, you need to ask access, and unless it's like close to GA, you will probably get it. But you need to ask Microsoft to like give you access, white glove access, basically. And if it's a public preview, it means you can use it. It's available just like it's GA available, but there is one small line in the contract. There is no support on it. So what we are saying, you can use it, you can test it, you can POC it, you can validate if you like what you see, but do not use it for production, because if something goes wrong, you will not get support from Microsoft on it. So, well, you will get support, but there are no SLAs, I should put it like that. So in short, never use something that is in preview for a production workload. But preview is typically so we go from internal to private preview to public preview to general available. That's I would say, the roadmap within Microsoft deployments. So if you see preview on my slide, it could well be that's already GA by now. So sometimes I need to update my slides every week. I didn't check it today, but I think Confidential Ledger, for example, is very close to GA or is already GA at the moment we're recording this session. Anyway, and then on top of those, there is I would say the developer tools and ISV partners. So you will see it down my slide, but some confidential compute technology requires a lot of work to make your application run on it. Others are transparent and work out of the box. So to make those things happen, we have SDKs available to reprogram your application, so to recode it. But we also have partners who are doing wrapping your application code. So basically what they do, they take your application code, they put their code around it, and then you can deploy it on a confidential compute stack. Doing that is fast, but the downside is that you add another party that you need to trust, because if you do the wrapping, then it means you are also trusting their code to be safe. So that's the only caveat I would say in that story, but it's I think that's a nice in between. If you want to move fast, you can do that, and then you buy some time to actually make your application native confidential compute aware. But I'll explain why that's important, and that's pretty much why we have Intel and AMD on the slides. Some definitions, I think by now you all know. I explained most of them during the talk already. I think it's clear what confidential compute is. It's important that for us, it's hardware based. So it's not a software, I don't know, software layer in between the hardware machine, Hyper-V, and then your VM running in Azure or something. This is really a physical chip in the server where your VM or your application or your container or whatever your SQL DB is running. And why? Because, well, I think personally, but that's also our vision as Microsoft, is that that's the most difficult part to hack, because typically you will need physical access to the chip to, I don't know, solder a wire on top of it or replace the chip with another bootloader or BIOS or whatever. And for those who already visited a cloud data center or a Microsoft data center, then you know it's very, very, very difficult to get in. So every measure that you can take from a physical security point of view is being taken. So I think if that becomes your I would say your reason to not trust a cloud provider, then I think most data centers should actually buy a very big mirror and look at their own security of their data center, because I'm pretty secure, or pretty convinced, I would say, that our security is probably beating any local data center anyway. But that's why we use the hardware one. And also, like I mentioned, so it's not always an attack from a rogue state. It can also be another application on your host. It can be the OS that was compromised, the hypervisor, your own colleagues, your service provider, so Microsoft, or maybe your partner, or just someone who is maybe just replacing the patch cables in your rack could also actually touch your server. So all these people, or all these instances, or all these I would say items could be of risk, and hence confidential compute. So that's a little bit setting the scene. Why the hardware? I just explained it, so I'll skip this one. And then this is, I think, without talking about the actual product, explaining how we see the landscape. And if you go from left to right, that's basically what I said. Left is the easy button. So that's the one where I say, hey, I want confidential compute. I want to flick a switch on Azure, and I have confidential compute, and I can go to bed and sleep with ease and not be worried something will happen. We have that. It's great. It's confidential, or it's more confidential, I should say, but it's not the most confidential way of doing things. And I'll explain the differences later. Just keep that in mind. So the easy button also comes with a downside. It is confidential. It is probably more confidential than what you would know today, but it can be more confidential with some effort. Then in the middle, of course, you always have the balanced one, where you say, I want to do some work, but I don't want to throw out everything and start from scratch. There we have also solutions. And then the I would say the holy grail of confidential compute, that's pretty much the one where you throw out everything you have and you start from scratch. In my opinion, that's probably not realistic, because, well, from Microsoft's point of view, of course, we like to say greenfield is the best, and everyone will agree. But in reality, you still have legacy, and you have stuff that you have, and it is what it is. You have to keep everything on, and then this is not always an option. So in my opinion, you start on the left, and then you will slowly move to the right. For example, when an application goes end of life, the next version of that application or alternative will probably be one that is cloud native confidential compute aware. And then you can take it like that. But in the meantime, we have other options to keep what you already have still confidential, or more confidential than what you have today. So in my opinion, this is a little bit like moving from on-prem to cloud. In the ideal world, you would say from today to tomorrow, I move everything to cloud and I close my data center. That's probably I would say, our holy grail from a cloud provider. Realistically, with all my customers over the past 5 years, I have never had one customer who had nothing left on-prem, either because they wanted it, or because they have an OT environment where they need to have something on-prem, or they cannot move everything to cloud because of legislation or any other instances that are preventing them from doing so. So I think there is no black and white in nothing. It's always gray, and this is also such an example, I would say. So I think the in-between one is where everyone will end up anyway. And so going left to right, we go from I would say the trusted launch VMs to AMD VMs to all the way the Intel SGX VMs. But I'll try to explain what that actually means. This is what I just said. So you have on the left, you have the easy ones. On the right, you have the enclaves, like the Face ID story that I gave. And across all those things are the confidential services. And then you don't worry about it, because it's a PaaS service, and it's basically Microsoft doing the heavy weightlifting of moving everything to a confidential compute stack. And that's why not everything is confidential compute out of the box on day one, because I mean, if you have PaaS, it's just someone else who is doing the work, right? So we also need to adapt the code and change the way the software works to be able to support those kind of things. Then the IaaS offering. So yeah, the dinosaur IT stuff, I would say. This is what we call the trust ladder. So the higher you go up the stairs, the more secure it gets. And the easy one, which I would say every customer should probably enable this, is the trusted launch VMs. So this is the least confidential one, I would say, but it's still more confidential than no confidential compute. What this will do is pretty much, well, you can take it from the right here. It will prevent the VM from having malicious bootkits on the machine. So basically, this is the TPM chip, the vTPM chip, so the trusted platform module that you, if you have deployed Windows 11, for example, you will have seen that your installation requires you to have TPM either as a chip on your motherboard or as a software token that you can enable in the BIOS, which allows the OS to validate that there was no tampering with the bootloader, with the BIOS, and so on. This is what trusted launch VMs do as well. So it's a flick of a switch in Azure Portal where you can enable any VM. So, well, not any VM, but most VM SKUs that we have support this today. And then you have some sort of protection against malicious bootloaders and so on. And drivers, for example. And for example, a use case that I once read upon is, I think it was used in Ukraine, and it was not related to the war. But from what I remember from the story, they actually, a malicious state attacked their electricity suppliers, and they changed the drivers of the network cards of their management stations to control the breakers throughout the country. And as soon as as the attack took place, basically what happened, they killed the access remotely from the management stations towards those breakers, meaning they took out the breakers from their hacking location, and then the actual people, the operators, were unable to start them up again because they had no more remote access, because they installed bootkits on the machines probably months and months before without anyone noticing. So yeah, it's not fully secure, but it will help you preventing that kind of stuff from happening. And it's not that an extra cost, and it does not require any replatforming or recoding or whatever. So it's I would say a no-brainer to enable those kind of things. Then next on the ladder is the confidential VM. So this is running on the AMD CPU, so the EPIC CPUs for those who are interested. And what you see here is, as mentioned also on the slide, so what are you protecting your data and your VM from is basically from Microsoft. So using confidential VMs, you do trust your own VM administrator, your partner who is maintaining your environment, and you also trust the OS running on top of the machine. So for example, Windows Server or Ubuntu or Red Hat or whatever. But what you do not trust is the hypervisor underneath. So in our case, Hyper-V. You do not trust Microsoft personnel running the data centers. You don't trust the bootkits because it's stacking up from the previous options. And why is this a very interesting one? Because for those who know Azure, basically, if you, for example, if you say I start with a VM with 2 CPUs and 8 gigs of memory, if you need 4 CPUs and 16 gigs of memory, what you do is you shut down the machine, you change the size of the VM, and you restart the machine, then voila, your machine has 4 CPUs and 16 gigs of memory. Or the other way around, if you start large and you want to go smaller during holidays, you can do that. Just shut down the machine, change I would say the specs, you restart the machines, and it's done. It's the same thing for confidential VM. So what you can do is you have a machine, it is not confidential today, you shut it down, you change I would say the hardware type of the machine from a non-confidential SKU to an AMD EPIC SKU, you restart the machine and your machine is confidential. So it's really, to say it a little bit salesy, it's lift and shift. So it's with a flick of a switch, you can move your VM to confidential VM, but with the caveat that you are trusting the OS and you're trusting your own VM admin. So, which I think is fair because it's the same guy you trust on-prem today. So if you don't trust him on-prem, maybe that's another issue that will not be solved by confidential technology. But that's out there today, and that's why most customers are very interested in this one, because it's painless. And then the holy grail, the enclaves. So the same concept as the iPhone example, for example. This is where you have Xeon CPUs, and they come with an SGX chip on top of the CPU. They don't trust anything, so only the application is trusted. So the OS is not trusted, the VM admin, nothing is trusted except for really the application that is running the code. The downside of using SGX is that SGX requires you to customize your code, so it cannot run standard code. You need to adapt your application code to support SGX, or like I mentioned before, you need to use a third-party software that will wrap a layer of code around your existing application so it can run on SGX, and then it's doing some sort of emulation. But doing that, then you include that third party as in your trusted compute base. So it has some downside, but it's in between. So SGX is also the oldest one, or I would say the most experienced one. So it has been around the longest, but it requires the most effort to use it. And SGX is what we use for SQL, for example. It's used for the confidential ledger. It's used for AKS. So running on top of SGX today, it will come for AMD as well, the AKS one. Yeah, and so on. So the mostly used is SGX, unless it's for the VMs, the confidential VM, that's AMD today. And that one will also join the AKS one. Now, if we zoom in, which is what I just did, there you say, I trust my app and the chip itself, because it's a hardware chip, right? This is a little bit how it goes. So that's what I explained. Basically, you have the chip in the hardware box, and then you have your app, and this is the only ones that are trusted. All the rest is pretty much zero trust, so seen as potential attacker. Moving forward, you have the example of containers. Is the exact same discussion as with the VM, but you take it one step higher, and then you only trust the container itself. You don't trust the node, you don't trust the node admin, you don't trust the AKS admin, which is Microsoft in this case. But again, your container needs to be SGX compatible, so you need to rewrite the code or use the wrapper, as mentioned. Those wrappers these are like ISVs who actually have solutions to help you with that. They do the wrapping, so do have solutions for that. I cannot speak for it because, well, it's their solution, but I welcome you to look at our marketplace and to read up if you are interested in those topics as well. Then the AMD ones is what I explained basically. This was announced about a year ago. Well, I think is it the 30th today? I think it is. So this was actually announced a year ago that we would have it. And it is available today in Europe North and Europe West. And again, it will scale out, but we need more chips to be able to do so. What else? Well, like I mentioned, this is the same slide. So what do we trust? We trust the OS, the guest OS, and we trust the CPU, of course, and then your code. So we are adding the guest OS layer to your trusted compute base. And then, of course, the admin who is managing that OS is also being trusted. But if you compare to having nothing, you are still taking out a lot of risk by doing so. And I think the main reason to do so is you take Microsoft out of the equation, which is typically the biggest blocker to not move to cloud with certain workloads. I added a link down here, which is, I added it because it's a question I often get. People always say that's great, but encryption has a cost. And with a cost, I mean performance. What is the impact of using an AMD with encryption versus an AMD without, or an Intel? If you look at the link, it's basically it's a study from AMD, of course. So you could argue that it's a little bit biased, but they share the complete set of benchmarks, how they tested, and so on. So I do trust it. And what you see is the performance hit like for like is between 2 and 5% CPU wise. So I think it's a small price to pay for the added security. For sure, if you check out your CPU loads, you will see that it's mostly not used at 100% all the time. These are the SKUs for Intel. So basically left Intel, right AMD. It's not important for the session. What is important is at the bottom is that we have changed pricing. So you pretty much don't pay extra for the confidential compute. So on a per core point of view, it's the same price, which is, well, I think it's key. to be able to get it into the market and being used by customers. So there is no, you don't pay extra for using more secure environments. Trusted launch, what I said, so it's secure boot and VTPM, so preventing you from boot and rootkits. I won't zoom into that again. And this is how you enable it. So it's really going into when you create a machine, you say, I want to enable a secure boot and I want to enable the VTPM, put it to yes, and that's all you have to do. There is no nothing else to do. So it's painless, I would say. Then the PaaS offerings mentioned before. So we have the SQL always encrypted with secure enclaves. So we already had always encrypted for the SQL fans in the audience. But the difference here is when you use always encrypted, you lose some features from SQL. Some things cannot be done. You cannot run all types of queries. And I'm not a SQL expert by far, but I know it has limitations. Whereas, and also the decryption of the data is always done on the client side, which has a performance impact. Whereas if you use always encrypted with secure enclaves, so with Intel SGX underneath, then you can do all kind of queries. So basically you get the, I would say, good old SQL back. And also the decryption is done on the server side, so on the SQL server itself in the SGX chip. So the performance should be on par with normal SQL as well. So you're not preventing performance issues. You're preventing performance issues on the client side. Confidential ledger is pretty much what you would think of a ledger. So main use case, and I will come back to it on the HR story that I gave. It's immutable logging. So it would allow you to put away logging that cannot be altered. So the same way that Bitcoin works, that you can see transactions, you can add stuff, but you cannot take it away. So you can append, you can read, everyone can validate, check, but you cannot change whatever is in there. So use case could be the HR, but you could also think of it, for example, supply chain of the future kind of stories where it allows you to prove to the next party in line that you did your thing and then it was registered. It could also be a way to, I don't know, validate checks in the food chain that you did the right things, you took the right temperatures in the refrigerators at the right point in time and so on. That cannot be altered. So the confidential ledger is basically running the ledger within your Azure subscription and then using it as a secure way of logging data, and it cannot be deleted. So you can delete the entire ledger, but then everything is gone and you would see who did that. So it would be a very big step to take. And also if you give someone access to delete that kind of stuff, then I would really hope that you trust that person. But you cannot change anything within the ledger. And it's also, of course, high available with 3 nodes and so on. So it's a high available and secure way of doing things. The attestation is that service that I explained that will basically allow you to validate if the machine that you are trying to use or the CPU or the service, that it was not tampered with. So it gives you, and that's why there is a little logo of the stamp. It gives you like a seal of approval that the machine or service that you will use for your query or your workload is validated and safe. So it has not been tampered with. And the key vault managed HSM is what I said. So it's a key vault, a regular key vault, but instead using the SGX enclaves to store the keys, hence using SGX, and it is dedicated to one customer. So the hardware is really for you and for you only. And this brings me back to that HR scenario. So what we did in this scenario is we replaced the normal logging with sensitive logging. So basically the logs are going to the confidential ledger instead of to a normal log analytics workspace, for example. The key vault storing the keys to do everything is the managed one. On the SQL side, we have the SQL with always encrypted using the secure enclaves. We use Azure attestation to make sure that all these components are what we say they are, so that they have not been tampered with. On the VM that is hosting the web app is actually running on an AMD confidential VM, so it's secure, but you trust the VM admin. And how are we blocking all the malicious story that I explained before? Well, the HR admin, whatever he does, is being logged in the ledger, so the logs cannot be altered. If he can still change stuff because he needs to do his job, but whatever he changes will get logged and cannot be tampered with. So yeah, you can change stuff, but we will be able to prove it, and that's key. From the SQL VM admin, or in this case, this is a PaaS service, you cannot see within the data because it's running on the SGX, and only the application can access the SGX, because SGX only trusts the application, if you remember the previous slide. And then from the DBA who is managing the SQL with the SQL Management Studio software, he cannot actually see it. And if you have a movie of someone running the code, I didn't enter it in here, but if you look there, he can actually do his job. So he can do, he can still connect to the DB, do queries. But if he actually does a query, for example, to say, I want to see all the salaries of everyone, he will just see encrypted lines of code. So the SGX is aware that he has not the right authority to see the data, and it will only show the encrypted line. So he can do his job as a DBA, but he cannot read the data that is in the SQL because he's not an HR admin. So there, if you want to see that, I welcome you to look at that link where you can see that that movie. It's really nice, and you can deploy it yourself on an Azure subscription if you like. A little bit more on that Ledger one. The use cases are well everywhere that you have logging, where you want to make sure that it's being able to being checked by any party and it cannot be changed. I think the confidential ledger comes into play. So it can be a supply chain, but it can also be I don't know, maybe selling of houses. It can be in the finance world. It can be pretty much everywhere. And why? Well, I think the story is there. It's automated, so it's probably cheaper than having someone else do it, and there is no room for human mistakes. It's tamper-proof. I mentioned that you can audit and validate, so any party can always validate, just like you would do with a normal blockchain out there already today. The only difference is this one is running in your subscription, in your tenant, so it's a private ledger basically, running on SGX technology. Yeah, I already mentioned this. May be important or interested. You don't have to use AAD to authenticate to it. So it can also run certificate-based, which is something that I've seen sometimes come up as well, because some parties do not like AAD or don't want to use that and only want to work with certificate. And from what I understood from the product team, security teams really like to have the certificate-based option as well. So since you guys are a security audience, I might think that's also good to know. What else is there? Yeah, I already explained this one. Why is the good fit? In essence of time, I'll skip it, but I think I already explained it. This is again the HR demo with a link to the demo on GitHub. So there you can download the code and redeploy it and try it out and do what the admin would do, and then do it with and without confidential, and then you see the lines or not, depending on which one you are running. And then there is the use case. So this is, for example, of the secure ledger, a use case that was done with Avanade, is where they use the ledger to store the sensors from a car. So the story that they have is we have today we have Tesla and stuff that is doing autopilot, but it's not really autonomous. At one point, I think Mercedes just announced it, that they will be able to drive their cars autonomous in certain use cases in Germany and probably around the globe soon. But the main question why we don't have it today is what happens if two cars crash and one was being driven by a computer and the other one by a human being, for example, or maybe by two computers. Then who is to blame, right? And what they did is basically they are taking the sensor data from cars today, so not only from I would say the newer ones or the ones that have AI capabilities, and they put it all in a ledger. They can visualize it, they attest it with the Azure Attestation Service, and then what they actually can do, if a crash would happen, since that data is being sent to the ledger like constantly in a flow, they can pretty much run down the logs and compare what was the state when the two cars collided, who was turning what wheel, which pedals were pressed, or maybe you have an onboard camera that has footage of the situation showing the light was red, I don't know, stuff like that. that this is what they're doing today. So yeah, we have the you have the cool stuff with which will talk about as a final slide with NVIDIA, but this is also applicable to what we have on the road today. So not only the cars of tomorrow, but also the cars from yesterday, I would say. And this is an actual use case. So this is a public customer story. Of course, there is more in-depth information available on our website, but I thought this was again a good story. Why? Because I really like the stories about the cars of tomorrow, but in the end, we are still living today, and sometimes we only talk about the technology for stuff that's not out yet. And I like to also add stuff that you can use today, and I think this one is one of those examples, like the HR app, that is actually valid today, using the confidential compute technology today for a use case that we all benefit from today. And well, I added some links again on ACL itself, so on the Azure Confidential Ledger. What is the way? Well, this is privacy related. I added it. It's not a Microsoft slide. It's basically talking about confidentiality, anonymization. I've heard a lot of people outside and inside mention, yeah, but you don't need confidential compute because you can just anonymize data and then you can do what you want with PII data. I totally disagree with that because history has proven that even if you think that data is anonymized, the chances that you can re-identify the data is pretty large, actually. There is a great story, and I think I put in the links with the New York taxi rides, where they basically were able to use Instagram data together with anonymized data of New York taxis to define which celebrities tip the most. If you're into that stuff, then I welcome you to read that article. I really enjoyed it, and it's textbook example why anonymous data is probably not so anonymous as you think, or maybe it is today, but with the technology of tomorrow, it can be made personal data again. Same story with differential data and then the fully homomorphic encryption. Some of these things are still in theory, so they have not been proved, or they are run software level based, which is not what we want to do from a Microsoft point of view. And then using the differential privacy data, for example, that can be done. So that is being done also. But there you have the risk that, well, the risk you have to limit the amount of queries people can do because you add noise. So you change the numbers with a few percentages up to be able to prevent someone from being identified. But if you can do enough queries on the same data set, you can find the anomalies and then you can still identify people. So it limits the amount of queries you can give to your customer of the data set. So it's also not the holy grail. So I think also there confidential compute, with what I explained, can bring a value to these kind of use cases. Again, this is stuff from the confidential compute consortium. So as you can tell, they did that comparison between hardware DEs, which is what we do, versus homomorphic encryption versus TPMs. What is good, what is bad about it, what can it do, what can it not do? And then the conclusion is that nothing is perfect, I think. But it's good to have the, I would say, the overview, so you can put the right, I would say, building blocks on the right problems. And that's the main takeaway from this article. But again, this is just one page. It's a pretty elaborate article. I put it in there because I think if you're interested in confidential compute, you might also be interested in reading up on this kind of stuff. What I wanted to say in the end, confidential compute, by now you should be on board that it's designed to encrypt end-to-end. So data at rest, data in transit, awesome. And now we're adding data in use. Are we there yet? Entirely? Not at all. Do we have already stuff that is actually applicable in the world? I believe so. And we will for sure add more. And the main reason to do it is you do not trust Microsoft or any other cloud provider, right? If you want to take them out of the equation, I think confidential compute is one of the ways to do that, while still being able to benefit from using the cloud infrastructure. Yeah, the motivations of why would you want to do it, I think, are obvious. So I won't read it out loud again. What I wanted to talk about before we hit the hour is the confidential GPU. So this was announced last week, I believe. And basically, we are the first to bring NVIDIA to the table as well. So everything I just explained will get an extra party. So we will be adding NVIDIA to the story, and we'll be adding the A100 GPU, so the one that we already have for machine learning and so on. We'll also get the secure chip on top of their CPUs or their GPUs. What I wanted to share here, the use case is actually autonomous driving. So sorry, what the customer here wants to do, which is Bosch, well, it's a large auto manufacturing company. They want to take the images from the AI cameras in cars and then learn from those. So for example, I don't know, how do I detect a pedestrian, or how should I train my car not to drive through the red light, or whatever you can think of. That data that they collect is very sensitive. It is data from you as a driver, because where were you driving? Maybe who was in the car, because maybe there are microphones, but also who is being filmed. You are filming license plates from other cars. A pedestrian can be identifiable because you actually see them on the image. And today that data is very well kept close to them, because if that gets out, they have a big issue. Then there is GDPR in place protecting us from that kind of stuff. And yes, they can do it with confidential compute, but training images on CPUs, it's cumbersome. So it means that it will they will need a lot of CPUs, and then it becomes too expensive. And then you lose the benefit of cloud in a way, because it will be too expensive to do it. And that's where the GPUs come into play, because doing machine learning, typically GPUs are very valuable. And now we will have confidential GPUs. So we'll be able to use the power of the GPU while still keeping the data confidential, the exact same way I just explained. Let me see if I have a slide on this. So this is how it would be processed. Nope, I don't have a slide on it, but it's the same story as with as before. So like I said, once you know the logic behind it, it's the same. What you do is the image is only processed within the secure enclave on the GPU, and the model is trained in there, and the user or the VM or the application that is actually running the workload, he only gets the results saying, okay, I know compared to yesterday, I know better how to detect a child or a dog or a cat or a stroller or whatever. But I'm not sharing the data, so I'm not showing you the face. I'm not telling you the license plates of the cars and so on and so on. So that's the idea behind that as well. And that is in private preview now, or in public preview. I'm not sure. I think it's in private preview. The main thing is you can sign up for these things. So if you want to try those stuff, you have a use case, you are a customer, you know a customer, you want to play with it yourself out of interest, then by all means sign up. Reach out if you want to know more. Follow me on LinkedIn or on Twitter or whatever, because I do tend to share things that interest me related to the topic. So if you're interested, then I'm sure you might like it as well. These are all the links that I put out. So welcome to read. And with that, I am at my last slide, Ulrich.
Yeah.
So I think I went 3 minutes over time, which is still okay, I hope.
Yes, it's fine, no worries. To start with, let's say there's a 3-letter word for this that's called wow. So it's been an amazing journey. In any case, thank you for sharing. It's been quite a lot, and a lot also for us to be able to digest. I think that there's many different things that we've learned here. It's definitely an excellent initiative. It's an excellent initiative that anybody should basically start taking. There's almost no incremental costs. It's basically switching it on. There's nothing that anybody should be preventive from doing so. Even in terms of the calculation, there's no additional significant costs on processing it. The other thing that I'm not entirely agreeing with you on is the slides where you were making the differences between confidential computing and then some of the privacy preserving technologies, anonymization, pseudonymization, simply for the reason that they are complementary. And so In essence, you can do this, and on top of it, you can still find the right use case to build basically pseudonymization, anonymization, and we do have serious use cases where that does work. Of course, there are limits, but not to directly anonymization. Specifically with multi-party and fully homomorphic, that's just the reason why these things exist, is to fully enable that. But I think we definitely need to dive a little bit deeper at another occasion on how the key vaults mechanism can start working for, in this case, everything in relation also to the HSMs, because that's really something that people are looking for. And just the basic capabilities of storing the keys into these secure vaults is a very good way of handling this. So I'd say let's further dig into that, but also let's show how this this incremental thing can start to happen. Maybe one question that I did see coming in is a bit of the question. I mean, you're putting this more as a sort of an answer to a consideration of zero trust.
Mm-hmm.
So my question now is, because you didn't touch upon the zero trust as such, how does this relate, or how can you basically fill in zero trust to some extent, or to a large extent, with confidential computing?
I get the question. I think the main reason why we see a demand for this is the mistrust in us. So typically in the cloud provider, Microsoft is an American company. We are a European country. There is a lot of issues with that. We are doing our best, but it will never be enough, right? So the only way to...
It's also beyond your control, basically, in many cases.
Yeah. And then at one point you can start to discuss, if you don't trust this, then you should be going back to paper and pen, because that server on-prem is also probably made by someone in the US or in China or whatever. But the confidential compute part is, the idea there is you take it out of the equation, you take away the part that it's running on top of a motherboard made in a country that you might not trust, or there is a government in place that has rules that can make you give over the data. If you give over the data, but the data is encrypted 256 bits AES encryption, well, have fun with the data, I would say. So the zero trust, I wouldn't say it's from a security point of view. In essence, the way you look at it, I think it's more from a party trust, not from a source code. Well, you could discuss the trusted launch VMs are there, the attestations are there, helping you to make sure that you do that, but it's not zero trust, because you cannot attest something is safe if you don't know yet it was breached, right? So it's in there a bit, but for me the main reason to do confidentiality is to take the cloud provider out of the equation today. That's the main driver that I see at customers, that and not because they don't trust us, but more, I want to use your cloud, but I'm prevented from doing so by legislation, by GDPR, by whatever. And if I use this technology, then the GDPR board in country, they accept that as secure enough to prevent a leakage of PII data, for example. And that's we are having those discussions with those parties. It's not always easy, but that's great, because their feedback stops us from, well, gives us input to do more.
Yeah, that makes that makes sense. I think, I mean, some point in time we'll have to come up with a reason to basically clarify that how one relates to the other. But yeah, the point is very well taken. It's an answer to some of the concerns, and probably there will be need to put more energy into these concerns going forward. But that makes sense.
If I come back in 6 months from today, that there will be the list of new things will probably be doubled by then, or the storylines or the customer stories or whatever. It's I think from our side, and I think all up in the industry, we are at the step 1 of this technology. So it's still pioneer work. So that's why In use case, it's difficult because a customer has not only a SQL DB. They have a SQL DB and a web app and a storage account and so on. And today, still you cannot do end-to-end confidential computing on every stack for every application. And if you have one party that is not confidential, then the entire stack is not confidential. So that's where we're struggling today. But I think you need early adopters to make something standard. Yeah. So we need to somewhere, and that's where we are today.
Another question that I've seen coming in is in relation to how do you one, monitor, but secondly also how do you report? Because in this world, of course, there's lots of reasons to provide compliance, and compliance is to do, of course, with the proof. So how can you basically also ensure that all of the things that you mentioned, you can prove that they're there and that you basically indicate that it's active. So for instance, you say, okay, it's just basically turning on a switch on off to enable. Do you also have a dashboard that can show, okay, this is basically what has been done, and here's still some things missing?
So basically those things are by default already in Azure. So we have the Azure portal where you have Azure Monitor, you have Azure Advisor, and there you apply Azure policies where you can say, for example, a policy could be, I do not want virtual machines turned on that do not have trusted launch enabled. So then if a VM admin or whoever tries to create a machine that has not enabled trusted launch, the machine will not even be created. And then you can say, and if someone tries to do that, then I want to have a log entry in a log analytics workspace, or I want to have a monthly report showing me who tried to make what machine that was in violation of a policy, or if a policy is violated, then I want to have an email sent towards my security officer or whatever. The latter one is probably not what you want, because that person might get a lot of emails, and if you get a lot of emails, you stop reading them, and then that's an issue. So you probably want to have some sort of dashboard that shows you, look at this is important. But typically you would make policies that define what you define as a trusted environment. And then anything that is not fitted to that policy won't even be able to be deployed. That's how we already do it today. So an example could be, you cannot deploy stuff outside of West Europe. You can only deploy a VM in West Europe and not in, I don't know, Asia or the US or whatever. That could be a policy, and there we have a list of a lot of predefined policies. And then if that's not enough, you can make your own. And then it takes a little bit more effort, of course. And then we come into play, or you do it yourself, or a partner does it, or whatever.
All right. Okay. Thank you very much, Tim. I think that's definitely a very good overview to start with, because this is the start of the game. But thanks for showing how this is being put together, and definitely looking forward to seeing you back then in about 6 months with the updates on all of this. So that's an open invitation in any case. All right. With this, I'd say we'll continue with these series in the next couple of weeks. So we have planned them again this year every month, and so next month we'll be talking a little bit more about cases on multi-party computation together with Vault. Maybe we'll see you there as well.
Yeah, I'm gonna say I might show up myself to learn something new.
Super. Okay, thank you so much, Tim. Have a great afternoon, and we'll be in touch shortly.
Okay, take care. Thanks all.
Bye.
Bye-bye.